tension is electric. The world holds its breath. After months in the vast, unforgiving void of space, two heroes are moments away from touching home soil. Or rather, home water. The skies crack open, the ocean beckons, and history is about to be written in the waves. This is Splashdown. The final descent is nothing short of a white-knuckle thrill ride. The spacecraft, a blazing fireball just minutes ago, now drifts gracefully under four massive parachutes, each one a silent guardian, ensuring a safe return. The Atlantic Ocean below is a mirror, calm, serene, almost as if nature itself is pausing to witness this moment. Parachute deploy, right on time. The call echoes through mission control. Cheers erupt. The clock ticks down. Inside the capsule, two veterans of the cosmos brace themselves. Their hearts race, not from fear, but from the sheer adrenaline of re-entering a world they left behind. Altitude 6,000 feet. Standing by for main chute deployment. The cameras catch every second, every sway of the parachutes, every shift of the capsule against the azure sky. The tension is palpable. Then, main shoots out, all four deployed. Look at that. The crowd goes wild. The sight is breathtaking. Four brilliant orange and white canopies bloom like flowers in the sky, slowing the spacecraft from a death-defying plunge to a gentle drift. The numbers flash on screens. Speed dropping, altitude falling. 500 meters. Brace for splashdown. The capsule hovers for a heartbeat, then splash. A geyser of seawater erupts as the spacecraft kisses the ocean. The sound is thunderous, triumphant. Inside, the astronauts are jolted, but safe. The water settles. The capsule bobs gently, a tiny speck in the vast blue. Splashdown confirmed. Welcome home. The words send chills down spines. They're back. After 212 days in orbit, after circling Earth over 3,000 times, after conducting groundbreaking experiments and staring into the infinite abyss, they have returned. The recovery teams spring into action. Speedboats cut through the waves, racing toward the capsule. Safety checks begin, sniffing for toxic fumes, securing the area. Every second counts. Recovery team approaching, all systems nominal. The first boat reaches the capsule. A team member climbs aboard, knocking on the hull, a symbolic welcome back to Earth. The astronauts respond with thumbs up. They're alive. They're safe. The main recovery ship, a floating fortress of technology, moves in. A crane extends. Cables are attached. The capsule is hoisted from the water, dripping, scorched from re-entry. A badge of honor. It's placed gently on the deck, preparing to open the hatch. The moment everyone has waited for. Medics stand ready. The hatch unseals with a hiss. Sunlight floods the interior, and there they are, Butch Wilmore and Suni Williams, smiling, weary, but unbroken. The first breath of fresh air, the first unassisted step. The weight of gravity feels foreign, but the feeling of solid ground beneath their feet is priceless. Mission complete. You are home. The world exhales. Tears flow, families embrace. The journey is over, but the legacy, that's just beginning. This was more than a return. This was a triumph of human endurance, a testament to courage, a victory for all of us. Welcome back, heroes. Earth missed you. The Gulf of Mexico stretches endlessly beneath the spacecraft, its surface glittering like shattered glass under the brutal afternoon sun. Inside the scorched Dragon capsule, every breath feels heavier, every heartbeat louder. This isn't just re-entry. This is a fiery rebirth, a meteor made by mankind screaming home at 17,500 miles per hour. The plasma sheath glows violet outside the windows, temperatures soaring to 3,500 degrees Fahrenheit, hotter than lava. Yet inside, two of NASA's most seasoned astronauts remain eerily calm. "Drogue's out!" The call cracks through the radio static like a gunshot. Two small parachutes blast free at 18,000 feet, violently yanking the capsule from its supersonic death dive. The G-forces slam the crew into their seats. This is the moment where spacecraft turn to shrapnel. But Dragon holds. Then, the miracle unfolds. Four massive main chutes erupt at 6,000 feet, their orange and white canopies exploding open like fireworks against the blue. The capsule's descent slows to a surreal 16 miles per hour, a walking pace after riding a lightning bolt. Cameras on chase planes capture every millisecond. The parachutes twisting, the ocean rising, the capsule swinging like a pendulum beneath its nylon lifelines. 500 meters. Brace! The Atlantic swallows them whole. A titanic splash rockets seawater 30 feet into the air as the capsule punches through the surface. The impact would snap bones if not for NASA's crushable seats, a technology stolen from race car engineering. For 3 heartbeats, there's silence. Then, splashdown! Repeat, splashdown. Crew is home. The recovery teams are already moving. Black Hawk choppers circle overhead as swift boats carve through the waves at 50 knots. The first divers reach the bobbing capsule in under 90 seconds, slapping the hull in a Morse code of triumph. Dragon freedom. This is recovery. Smell any hydrazine? A pause, then Commander Wilmore's voice, steady as stone. Negative. Just ocean air. The danger isn't over. Residual thruster fuel could turn the capsule into a bomb, but the sniff tests come back clean. Now comes the ballet of precision. Divers securing flotation collars, winching the spacecraft onto the deck of the SS Megan, a recovery ship packed with space-grade medical pods. As the hatch cracks open, the world sees its first glimpse of the crew since launch. Suni Williams emerges squinting, her zero-G muscle atrophy obvious as she struggles with Earth's gravity. But her grin? Atomic. Behind her, Butch Wilmore runs a hand along the capsule's charred hull, a pilot saying goodbye to his ship. The data pouring in is revolutionary. This Dragon carried next-gen radiation sensors that logged cosmic ray spikes during solar storms. Its heat shield, upgraded with Starship-grade alloys, endured re-entry 17% cooler than predicted. Every scorch mark tells a story. A helicopter whisks the astronauts to shore, where NASA's anti-gravity wheelchairs await. Not for injury, but because standing after 6 months in space can literally make you pass out. As the sun dips below the horizon, a single tweet rockets across the globe from NASA's account. Earth to Dragon, welcome home. In Houston's mission control, a tradition plays out. The passing of the mission pin, from flight director to capsule communicator. It's over. But in the quiet, as recovery teams scrub salt water from the capsule, one truth echoes. Humanity just stole another victory from the void. The Atlantic sunrise paints the recovery zone in molten gold as the SpaceX Go Navigator's crew springs to action. This isn't just another splashdown, it's the triumphant finale of the first crewed Starliner mission, proving Boeing's spacecraft can safely return humans from orbit. The air crackles with tension as infrared cameras aboard NASA's WB-57 chase plane lock onto the descending capsule, its heat shield still glowing cherry red from the brutal re-entry. Starliner, Houston. We show you at 25,000 feet and stable, calls Capcom in the tense silence of mission control. The spacecraft's innovative, smart parachute system begins its precision sequence. First, the drogue shoots fire with a sharp crack, audible even over radio. Then the massive 77-foot mains blossom like mechanical flowers against the cobalt sky. This next-gen parachute system, redesigned after early test failures, deploys with flawless precision. Inside the capsule, Butch Wilmore's experienced hands hover over the manual controls. Though Starliner's autonomous systems have performed perfectly, NASA's tradition of human oversight means he's ready to take control if needed. Beside him, Suni Williams monitors the spacecraft's vitals on a cutting-edge glass cockpit display that's light years ahead of old analog systems. The display flashes green across the board, altitude, descent rate, hull integrity, all nominal. 500 meters. Crew, brace for impact. The warning comes just as the first salt spray hits the windows. Starliner's landing airbags inflate in milliseconds, creating a cushioned ring around the base of the capsule. The splashdown sends a geyser of seawater 50 feet into the air, the impact softened by NASA's newly developed crushable aluminum honeycomb structure in the crew seats. Before the waves even settle, the recovery fleet springs into action. A SpaceX fast boat reaches the bobbing capsule in under 2 minutes, its crew deploying the new Shark Shield, an electromagnetic field generator to deter curious marine life. Divers in advanced contamination suits quickly attach stabilizing pontoons, while sensors sniff for any trace of toxic hypergolic fuels. The readings come back clean. Starliner's redesigned thruster system has purged perfectly. On the recovery ship's deck, NASA's new mobile cleanroom stands ready, its positive pressure system ensuring the astronauts won't breathe a single germ after their immune systems spent months in the sterile space environment. Medical teams in blue isolation suits monitor the hatch opening through augmented reality visors that overlay vital signs in real time. As the hatch swings open, the world gets its first look at space-worn Starliner's interior. The walls lined with next-generation radiation, shielding that's already providing invaluable data for future Mars missions. Suni emerges first, her movements deliberately slow after 214 days in microgravity. She pauses to run a hand along the capsule's scorched exterior, feeling the pitting from countless micrometeoroid impacts, each one telling a story of survival in the orbital shooting gallery. The recovery team's new exoskeleton-assisted gurney makes lifting the astronauts effortless, while embedded sensors in their flight suits immediately begin transmitting medical data to Houston. Nearby, a team in hazmat suits carefully extracts Starliner's black box, actually a neon orange sphere containing priceless data on the heat shield's performance during re-entry. On the bridge of the recovery ship, NASA administrator watches the proceedings with quiet pride. This successful return proves America now has 2 independent crew transportation systems, a redundancy that ensures uninterrupted access to space. His tablet displays preliminary data showing Starliner's landing was within 500 meters of the target point, an unprecedented accuracy for a first crewed return. As the astronauts are helped into the crew transport vehicle, the recovery team begins the delicate process of securing Starliner for its journey back to port. The capsule will undergo months of intense study, every scorch mark analyzed, every system tested, all contributing to the evolution of safer, more capable spacecraft for the coming era of lunar exploration. The morning sun climbs higher as the recovery ships turn towards shore, their precious cargo safely aboard. Another chapter in human spaceflight closes perfectly, even as the next one, featuring moonbound Orion capsules and commercial space stations, is already being written. The Gulf of Mexico lies unnaturally still as dawn breaks, its glassy surface reflecting the fiery streaks of plasma still cooling in the upper atmosphere. This isn't just a homecoming, it's a resurrection. The scorched Starliner capsule bobs gently, its advanced thermal protection system having endured temperatures that would vaporize steel, now hissing as seawater meets superheated ceramic tiles. Inside the silent capsule, a symphony of cutting-edge technology springs to life. The spacecraft's autonomous systems, having just survived the most violent phase of descent, now activate the post-splashdown sequence with robotic precision. NASA's new smart buoyancy system automatically adjusts internal pressure to compensate for any potential hull breaches, a lesson hard-learned from earlier test flights. The capsule's AI begins transmitting terabytes of re-entry data through laser-linked satellites before the recovery teams even make contact. Starliner, Houston. We're seeing perfect data downlink. All recovery assets are go. The voice from Mission Control carries a barely contained excitement. This return marks the first successful demonstration of Boeing's revolutionary skip re-entry technique, where the spacecraft briefly bounced off the upper atmosphere like a stone across a pond, bleeding off speed while reducing G-forces on the crew by an astonishing 40%. On the recovery ship's command deck, engineers monitor holographic displays showing real-time radiation levels. Starliner carried experimental quantum radiation sensors that could detect individual cosmic rays, data that will prove invaluable for future Mars missions. The readings confirm what everyone hoped. The capsule's innovative water wall shielding, which stores drinking water in a protective shell around the crew compartment, reduced radiation exposure by nearly 60% compared to traditional designs. The first recovery diver reaches the capsule and attaches a new biometric sensor array to the hull. Within seconds, it detects 2 strong heartbeats inside. "Vitals nominal," comes the shout over the recovery net. The divers work with practiced efficiency, deploying the new electromagnetic containment system around the capsule's thrusters, a failsafe against any residual toxic fuel that might have survived the rigorous purge sequence. As the recovery crane gently lifts Starliner onto the deck, thermal cameras reveal something extraordinary. The capsule's base shows uneven heating patterns. That's the variable density TPS working exactly as designed, murmurs a Boeing engineer watching the data stream in. The revolutionary heat shield, 3D printed with gradient materials that change density millimeter by millimeter, has redistributed the plasma flow perfectly during re-entry. Inside the mobile clean room, the astronauts undergo rapid debriefing through augmented reality interfaces. Their eye movements and pupil dilation are tracked by NASA's new neuroadaptive systems, assessing cognitive function after prolonged weightlessness. Meanwhile, a robotic arm extracts the black box, actually a sphere of crystalline data storage capable of surviving a direct nuclear strike, containing every millisecond of the descent's telemetry. On shore, a team of xenobiologists waits impatiently for a special payload. Hidden in a sealed compartment are petri dishes containing extremophile bacteria that spent 6 months exposed to the vacuum of space, part of groundbreaking research into the origins of life in the universe. Their survival could rewrite textbooks on panspermia theory. As the sun climbs higher, the significance of this moment becomes clear. This isn't just the end of a mission, it's the beginning of a new era. The technologies proven today, the AI-guided re-entry, the adaptive heat shield, the quantum radiation sensors, will form the backbone of the coming Artemis lunar missions and beyond. The recovery ships turn towards shore, their decks buzzing with activity. Somewhere in Houston, engineers are already feeding today's data into supercomputers, simulating how to make the next re-entry even smoother, the next landing even more precise. The ocean behind them settles, as if already forgetting the violence of the morning's events. But history won't. This splashdown will echo through the annals of space exploration, a perfect ending to an extraordinary journey and a brilliant prelude to what comes next.